All right, welcome everyone to week 9 of nand2tetris. It has been a while since we covered week 8 material. We had a combination of family vacations and various other things, but we are happy to be back in the swing of things. And once again, we were surprised. There's people watching these videos on YouTube, and people are starting to comment, and I don't think I even told Dan this. Someone commented the other week on our channel to say, "Hey, when are you guys gonna release week 2? What happened to week 2?" And I was like, "Oh, we didn't record it."
Yeah, we didn't record week 2? Shoot.
Remember that was the week I just had made it a hangout, not a hangout on air, so it like didn't record, and I just was like, "Oh well, that's fine. No one's watching this anyway." And the stats like last week. People are spending like 2 to 3 hours a week watching our nand2tetris videos, average like watch time. It's crazy.
That blows my mind.
Yeah, I can't believe that we are able to produce anything of value to other people, but yay for us, or for people getting value out of it, I guess.
Appreciate you guys watching. The guys and gals out there watching, thank you.
So, so let's dive into week 9. Week 9 is we got done with our virtual machine implementation, and before they throw us into writing a Jack compiler, they wanted to help us get familiar with the Jack programming language. And so week 9 is all about kind of doing one small kind of pre-made project, and then you're supposed to kind of go off from there and write your own little game of some kind in their high-level language. And so, Dan, why don't you take us away? What did you pick as your project?
Well, I guess I just decided to do a Flappy Bird clone. It's so bad that it probably should just be called a Crappy Bird, but oh well, it's just Flappy Bird. It's hardly the pinnacle of good coding, but I guess it was enough to give me a flavor for coding in Jack. Which, you know, was the point of this whole thing. So I'll know what we're doing when we're building the compiler. I'll probably just show some code in a minute, but like the main thing, like programming with Jack was pretty straightforward enough. Like there weren't a whole lot of gotchas, but what I continued to do from start to finish was forget to type do for just the functions that have side effects, but don't have a return value. Like I was constantly forgetting to type do, and then I'd get a compiler error when I tried to build it, and that never went away. I never forgot, or never started to get well, I would. It got better, but like I think up to my final last code change, I was still occasionally forgetting them here and there. Anyway, so I will share some screen here and make this happen. Let's see the screen.
Code or it didn't happen.
Right, exactly. All right, so can we see this? Good?
Yeah, showing up.
3 classes. I just kind of looked at their one example that they had in the code thing, and then just kind of went from there. Well, actually, I looked mainly at the structure, like what they do in the class. So all I've got here is a game variable, a instantiate thing, and start it and dispose it, and that's it. So it's the game class. It's a little more interesting because it has some of the class fields and things. So we got a bird, a single pipe that just gets recycled, and then some fields for storing things about the graphics and then the state of the game, if it's over or not, and the player's current score. So these are just some things that get set up for rendering purposes. Not super interesting. The pipe initialized gaps is a crappy little hack that we'll talk about in more detail soon. Dispose, of course, is just apparently the what's the term? I guess the idiomatic Jack. You write a dispose function for your destructor, I think.
Yeah.
So yeah, reset. It just kind of sets the game. I set it up so I can kind of loop it because it's really hard, just like the original Flappy Bird, and you're dying constantly, and it was getting to be a pain to reset the game manually. So this allows me to just play it over and over. And then basically you just have your standard game loop, just an infinite thing that just keeps running over and over and over again. Or basically just when it's redrawing the bird, I clear out the old bird first, and then do various update things like the effects of gravity, etc., check for collisions, or if I've landed on the floor, whatever. Then here it's just checking for scores. Is this still visible? Not sure. Yeah.
Yeah, the highlighted code is visible. Yeah.
If I have passed the pipe, then I gotta increment the score and then draw the bird. But this is because the is visible check basically is like if I fly off the top of the screen, I don't want to like die by hitting the so-called ceiling. I kind of want to just like fly off. So that's all it's checking there. Updating new pipe, and drawing various things. So nothing amazing. Just display the score at the end. Yeah, I don't know if there's much interesting here with Jack. Just various methods. Yeah, I didn't do like if there's anything super interesting or questions, like we can talk about it, but I don't want to like belabor the point. One thing, like the bird is, let me look at the bird code quickly. I don't think there's anything really exciting there either. Just more fields, some getters where I sort of just stopped worrying about doing good object-oriented programming. It's like, all right, just give me the state of this variable. So there's that. Yeah, nothing amazing here. The pipe is a little more interesting to talk about just because it's like the limitations I found with Jack is that it doesn't actually have any random number generation. That's not a thing. And you don't have a system timer. So, at least I didn't. So if there was, please let me know. So I have this thing where I simulate random things by I just have some quote random numbers I generated elsewhere and copied and pasted into here. So this is kind of leveraging the static stuff in the language where like all the variables are shared among instances of a class. So I have basically initialized gaps. Then there are these class functions that take care of like every time I pass by a pipe, it just grabs the next array element and then resets it once I've hit the end of the array, pops it back. So then in between games, like it doesn't always start off in the same order. You'll like be at this when you reset the game, it like still keeps track of this what the next gap is, so it doesn't seem like it's doing the same thing over and over again.
Right.
In practice, it felt okay, but it still feels like a crummy hack. I looked at some like if I'd had more time or interest, there were some interesting like bit shifting stuff for doing a pseudo random number generator. So that would have been next. I would have actually probably implemented something like that and then leveraged it here. But I don't think there are very more interesting things here. So maybe I'll just switch to the finished product.
Yes, show the game.
All right, so let's play some Crappy Bird. Oh wait, I gotta spin up. Stop. Did it stop? No animation. Fast. I don't know what that matters in this case. Okay. Here we go. My bird's a ball. And we are bouncing through pipes. Really, any key press here will work. You can see in the top left there's a little updating score you go through.
Oh, yeah.
Yeah, and I guess I should probably, man, I'm doing so good. I normally don't do this well. So I'm tempted to just keep going until I actually die. There we go. So there is collision detection. And it just displays a message, and you just hit a key, and it starts. And yeah, this is oh well, it kind of works.
Dude, that's awesome.
Boom. All right. So yeah, that's Flappy Bird and Jack.
Nicely done.
Other code that you're interested in? I don't think there's much, in the way of that interesting stuff. It's just an exercise in implementing Jack code.
Yeah. Can you just real quick? So it was a little bit hard for me to see. Maybe my screen resolution during the live hangout is not as good as the video afterwards. Okay. In that top left little score counter, were you displaying white text?
No. So just like I'll quick pull up the code for it. Let's see if I was looking in class. Display draw score. No, the actual like output print string thing provides a white background and then prints black text on top of it.
Yeah.
That's exactly what I wanted, so that worked out well for me.
Okay, cool. Yeah, because I was like, I could not find an API for like manipulating anything. It's so weird to like write in a language that only can interact with like an emulated terminal, so that I can't really touch it from a real terminal.
Yeah.
It was a learning curve, at least for me.
Yes, it was strange because when I've done like game stuff in the past, it's like you don't really want to wait a specified amount of time. You kind of want to like look at how much time has elapsed and do your calculations based on that. And so just the fact that the whole game loop is just do some stuff and then wait for, in my case, 100 milliseconds or whatever, and then do the next iteration through the loop. It seemed a little hacky, but oh, that was the other thing I just like culled from their example code. It was like, oh, how are they doing the game loop? Because they're doing a game. So that was what I pulled out of there. Was just to do the system wait call at the end of the game loop.
Yeah. Yeah, I'm like you mentioned, like that do keyword that you kept forgetting. I had the same issue, like forgetting to do the let whenever there's an assignment, or forgetting to do when you're just invoking a function. And like I'm glad they designed the language that way. At least I have a suspicion that I'm glad of that, for the reasons of it'll make a compiler way easier to write.
Yep.
But it was funny to me that like, you know, we've been talking as nand2tetris, like as you read through the book and all the examples, they keep talking about how they're building up to this high-level language. And then I get to Jack and I'm like, wait, there's no garbage collector? Wait, there's no, like, what the heck is this? There's, you know, when I come from writing Ruby all day or Clojure or something like that, and then you walk back to Jack, you're like, our definitions of high-level language are not the same, because I understand that this is a high-level language in some respects, but it does not have any of the like sugar syntax that I'm very used to at this point. So
That's true, but it is high level if you compare it to say hack.
yeah, the assembly language is something definitely high level. So it just is funny though. I think I mean, just when the book had mentioned like how we're building to this high level language, I just kept thinking of, I don't know, the languages I'm most familiar with, and not the languages that I learned in college. So,
Yeah.
anyway, I'm really glad you did a more interesting game. I ended up doing an implementation of Snake, and several things that are very similar to your implementation, and a few things that are different. So I'll just jump into the code here real quick. Let me share this. And then I'm going to stick to my screen. So very similar kind of to the beginning of yours. I like you did. I kind of just started by taking their example and just, you know, replacing square game with snake game, made my snake game, and very much like yours, it pretty much just has, in my case, since the game of snake is, I didn't implement scoring or anything like that, so it's even simpler than your game. And so it pretty much just has the snake. You know, what's the status of the snake? The main thing I wanted to try to get out of this week is a little bit more understanding of the language. And so I had a feeling, I don't know if this matches with your experience, Dan, but my intuition up front was that the thing that would bite me a lot in trying to implement this game would be the little things that I didn't know about the language. So what I kind of decided up front was, I was like, all right, I'm going to make this snake object, and the idea of the snake object is that I initialize it with an x and y coordinate, and then in this game loop, as it's running, I kind of am keeping track of like changing the direction that the snake is moving, and changing whether or not the snake should grow in size. And so I'm not like keeping track of how many frames have gone by since the last time the snake grew or anything like that, and I'm not doing collision detection. But what I did try to do is my snake implementation here, let's see, so my snake.check, what I wanted to do is have this idea that when you created a snake, it basically created like this pixel object, which gets initialized to the x and y coordinate where the snake is being initialized. And then I build a linked list that just contains that pixel. And then every time the snake crawls down, left, right, or whatever, I basically what I do is like chop off the tail of the snake and add a new pixel that is kind of in that direction from the head of the snake. So when I crawl down, for instance, here, I basically say, make sure I'm not at the bottom of the screen. This is like my little guard statement here.
Right.
And then I basically make a new pixel where I just increment the Y value based on the last value that's currently in the list, kind of my most recent pixel on the linked list. And then I can push that new pixel onto my list. And if I'm not currently increasing my size, then I also go ahead and shift the oldest value off of my linked list, if that makes sense. So I kind of ended up with like this queue. It's not really like a fully doubly linked list. It's just singly linked, but I also keep the linked list object also keeps a reference to the oldest value, just as a quick way for me to like throw it off the end.
Nice.
But what I really was like, I knew that my implementation of this linked list and then these pixel node objects that kind of they keep track of just a next value. It's just a singly linked list. Mm-hmm. And I knew I was going to get this thing wrong a couple of times. So I think the only really creative thing I did this week is I made a unit tests project.
Oh man!
And if it basically just symlinks in a couple of my other classes. So like my linked list.jack is here, and my pixelnode.jack is here, and my snake.jack is here. And then in my main.jack inside the unit test project, I just basically have this main function where I say, hey, run all my pixel node tests, run all my linked list tests, and run all my snake tests. And so I started off by just saying like, pixel node, like how should a pixel node behave? And so I just wrote like, this is not a testing framework, this is very terrible, but it just gave me some way to say, hey, I just want to say that I'm testing pixel node stuff, and then I want to like make a new pixel node object, and if I ask it for its x value, it should be 10, and if that's true, then print out a P, otherwise print out an F for failed the test. And I just kind of do a bunch of these very small little unit tests, and the end result of that is, I'll switch my shared screen here real quick to the virtual machine emulator. I have it running, so you can see this. But basically, I can just come over here and I can like load my unit tests library. And if I tell that to run, then I can see I get all these PPPPPs, right? And so I like got all my tests passing. So this was kind of like my chance just to experiment with the language, figure out like, can I actually build like a data, oh man, this is like the most basic word that I should remember as a programmer. Data structure, there we go. Can I build a data structure? Can I write an algorithm and have it not fail? So I think that was probably the best idea I had this week, was just creating some sort of a semblance of unit tests, some sort of automated test thing that gave me some confidence that the low-level components of my game were behaving correctly.
That's pretty cool.
So then from there, I can, my Snake game is just kind of made of those same things, obviously, and all it does besides the things that were tested is run the game loop and listen for keyboard input. And I couldn't think of any good way to write a test for that, which is why I didn't test it. And so this will probably be, I imagine, virtually impossible to actually see my snake moving. Let me see if I can. I'll just keep on pushing this X key, which is like my grow the snake, and maybe it's still only going to be 1 pixel wide, but if I grow it long enough forever, maybe it'll eventually become visible, sort of.
Yeah, I can see something moving around.
So it's like really flashy. I don't know if your graphics looked a lot smoother.
Oh, good. I optimized for sweet frame rates.
on your Flappy Bird implementation, built on the Jack machine. But yeah, so I mean, the main thing I could have done to make this a lot faster would be to like undraw the pixel nodes as I drop them. But instead of doing that and being a good programmer, I just blank the whole screen on every frame, which is the main reason. And like you can actually tell as I grow my snake, the frame rate drops noticeably because of having to walk my linked list and draw additional pixels. So this is all to say that I did a terrible job, but I actually feel like I learned the language pretty well, and my unit testing was actually pretty helpful, I think.
Oh, unit testing is awesome. Man, that was great.
So that's my game. It was a simpler game. We probably should have ended with Flappy Bird rather than beginning there. Um, but yeah, so I feel like it gave me a chance to kind of explore the language, and very much like you said, the main things that caught me off were just the things that they specifically mentioned in the book, like we
Yep.
wrote the language in this way to make a compiler simpler.
Yep.
Um,
No, I can't say they didn't warn me. They totally did.
yeah, and it definitely gives me a little appreciation for Rich Hickey and Matsumoto for their great work on Ruby and Clojure, because I'm sure there's lots of times that they could have put things in their language that would have made their job easier, and instead they made our jobs easier and optimized for our coding joy. Um,
Yep.
so many thanks to them. But I'm glad that I don't have to write those compilers, and instead I can write a Jack compiler.
Yeah, no kidding. I would not want to write something that compiled Ruby, that's for sure.
Yeah, that's true, because even the Clojure compiler, I mean, it's Lisp, and I'm sure the macro system is somewhat gnarly to work on, but at least it's Lisp syntax is pretty minimal syntax, whereas Ruby's like all the sugars, every sugar syntax that we thought of. Yeah, let's put that one in the language. So,
Yep. That's why we love it, though. That's why we love it.
indeed. Well, I don't think there's anything else really from this week. This was last week. I feel like we both kind of mentioned that the projects seemed to be getting iteratively more difficult, and
Yep.
this was a week where I felt like it went a step backwards in terms of difficulty.
Yeah, actually, when I actually sat down and did it, it was like, oh, it wasn't too bad.
Yeah, I feel like I think I psyched myself out a little too much early, and I spent more time like looking at the language specifications in that chapter. And in reality, if I just dove in a little bit faster, I think I probably would have gotten everything done faster.
The static stuff was what ended up being tricky for me because I couldn't find any good examples of it. Like it was mentioned in the documentation, but none of the examples were showing how it was actually used. So I was just like, well, let's just try some stuff and see if I can make it work. So.
Did you have a static field in your game then?
Yeah, just the pipe. The random numbers are kept in a static field.
Oh, okay. Yeah, I didn't notice that when you were showing your code. That's actually a good point. Now that I'm thinking back, I didn't put any statics into my program at all.
That's okay, because neither did the authors of the book. So at least they gave us that facility. But
they're like, here's this sort of global variable thing. You shouldn't use it, but we're writing it into the language anyway.
yeah, it was interesting. I'm trying to think if there are any real gotchas with it. I think the weird part was just how like the access to it was not any different from like accessing just like a member variable. It just knows, I guess, by the way you've defined it, how to like look it up and modify it. But you're not like once you define it as a static field, you're just kind of treating it as a member field of the instance. So it's interesting.
Yeah, I'll be curious once we get down into the implementation of the Jack compiler. I'll be curious to see if that causes me grief, because I have a feeling that it will, but
You'll be fine. You'll be fine.
We'll see. So Dan, do you want to plan on trying to do chapter 10 next week, or I haven't really looked enough through it. I know that the Jack compiler, it's like 2 projects, right? I think it's week 10 and 11.
Is that it? Are there 3 projects? Are there 3 weeks left or 2?
I think we have 3 weeks left. I actually have the course page pulled up here. So project 10 is compiler 1, syntax analysis. Project 11 is compiler 2, code generation. Project 12 is the operating system.
The operating system.
Wow. So I think that is the idea of like spinning up processes and allocating memory to processes and things like that. I can't imagine doing that in a week, so maybe maybe that one turns into 2 projects for us.
We'll see how that goes. Why don't we shoot for 1 week here, just because. Where did I stick this? I lost my Google Hangout window. There it is. All right. All right. Yeah, let's shoot for 1 week, and if like either of us thinks like, oh, never mind, this is going to be harder than I thought, then we can push it. But I'm
Yeah.
comfortable saying let's just target 1 week and see how it goes.
Okay, sounds good. Yeah, the only thing I will mention is 2 weeks from now. So I was thinking about this week.
Okay.
I've been getting started on that Code Mentors Utah organization,
Right.
and I have a couple of people who are interested in hanging out and kind of getting some help for new people learning to program. And so I was going to try and schedule that for the fourth Wednesday of this week, or of this month, sorry.
Yeah,
So that I think that's 2 weeks from now. Maybe is that 3 weeks from now? Anyway, I'll let you know as we get closer if there's a conflict or whatever. But we might just have to skip 1 week so that I can try to get the ball rolling on that project.
that's cool. Yeah, that's awesome.
All right. Well, thanks again, Dan, for joining me and for doing nand2tetris so that I'm not Google Hangouting with myself, and also for writing an amazing Flappy Bird with incredible frame rates on an emulated hardware platform.
So good. I'll push it up to GitHub so all of you Jack hackers can play some Flappy Bird in your spare time.
Jack hacker sounds like a derogatory term for some reason to me.
Well, I don't know if anyone's getting paid to write Jack, but that would be cool.
I was like, after I did my little unit testing, I thought I could be the guy who writes RSpec for Jack.
Oh,
And then I
man.
thought, no, I don't want to be the guy who wrote RSpec for Jack. But anyway, yeah, thanks again, Dan, and I guess we'll see all of you people next week, maybe 2 weeks. We'll see. Thanks.
All right. Good night.
Night.